EcoCar is a 4-year competition to convert a 2016 Chevy Camaro into a hybrid electric vehicle.
Keeping in mind all of the constraints that a real-world vehicle carries, such as customer satisfaction and real-world kind of road drivability. So
basically that means we design what kind of hybrid we want to build. If we get our Camaro in December, we'll get it. We're going to gut it, put in all our components, and then hopefully by the end of May have a working mule vehicle.
We have to make a road-legal car that customers will accept that's also a hybrid.
My department looks at modeling the dynamics of the vehicle, so predicting performance, 0 to 60 times, emissions, things like that.
I use MATLAB coding to create an algorithm that would take an input image and distinguish where the lines were on the road from a video feed.
Before we get the vehicle, predict what the performance is going to be. We also work with the control algorithms team to develop the electronic control units for the vehicle.
You actually get to define the entire performance of the car. You can implement things like traction control, launch control. You are the one that's implementing the charge sustaining and charge depleting modes. You essentially control exactly how the vehicle is driven by the driver.
Right now, most of the equipment we're using is just desktop computers, but once we start getting all the components, we're working with electric motors, building a battery pack. So a lot of the hands-on stuff we'll be doing is crimping wires, cutting wires, soldering.
We just started getting our garage training, so we will be using mills, scroll saws, sanders, that kind of thing. We have our own machine shop.
My favorite part about being on the team is seeing the end product. I was a member when this team built the Malibu, and seeing it go from a pile of wires and scrap metal basically into a functioning vehicle that we can drive around. It's the coolest feeling you can imagine.
This is a very technical and very complex project, and there's a lot of different moving components. So my team is working on modeling, looking at the team, looking at three-dimensional modeling of the vehicle, electrical team, wiring, things like that. So working between all of our departments, communicating so that we're all on the same page, all moving forward to the same goal.
Obviously, I'm the mechanical team lead, so I'm in charge of ensuring that all the components we're designing, such as the engine mounts, the transmission mounts, the cooling system for our engine, motor, and transmission, all are packaged correctly into the engine bay and Camaro in general, and also that the components are designed to withstand the forces that they'll be seeing, so we're doing FEA modeling and some CDF. I chose to work in the EcoCar lab because I thought that this capstone was extremely real-world applicable, so some of the other capstones aren't as hands-on or aren't as real-world, where we're working on a real project, we have real deadlines, we have real goals we want to meet, and we're going to see an outcome in May. We won't just have some model on SolidWorks. We're actually going to be milling and making these parts and then installing the engine to see if they work, so you get an actual outcome from the work you put in.
The reason Penn State Advanced Vehicle Team is so important is we come up with innovative designs that can actually influence automotive design and manufacturing in years to come. It's not uncommon for companies to see some ideas that we take and actually put them into use, because the end goal of this competition is to make a safe, functioning vehicle. The fact that a team like this can meet those requirements, usually the industry can find some merit in what we do. So we can be innovating for the future.